Hey guys, so I had 2003 FRQ Form B, which states let f be the function satisfying f prime of x equals x times the square root of the function of x for all real numbers x where f of 3 equals 25. A, find f double prime of 3. B, write an expression for y equals f of x by solving the differential equation dy dx equals x times the square root of y with the initial condition f of 3 equals 25. So, the first thing I did was write what was given, which is f prime of x equals x times the square root of f of x, and f of 3 equals 25. So it asks us to find the second derivative of f of 3. And so you start with the original, well, not the original equation, but you start with the first derivative to get the second, and you know you're going to have to be using product rule. And so I rewrote it to be x times the function of x to the 1/2. And so to take the second derivative, first you have to do first term times the derivative of the second term plus the second term times the derivative of the first. And so you see that it's the first term x times, and you use power rule and you bring down your 1/2, and then you subtract 1. And then also there's chain rule included too, because you have to include f prime of x. So you use power rule, and then you have to take the derivative of the inside of the function. And then it's just plus f of x to the 1/2, and then times 1 because the derivative of x is 1. And so this is how I rewrote it. X times f prime of x over 2 times the square root of f of x, because this was the term that was the negative 1/2. And then this is just plus f of x to the 1/2, so square root of f of x. Or if you want to write it differently, you can expand this term so that you get this. So it's x times what was given, this original equation, over 2 times the square root of f of x. And so then these two terms cancel each other out, and you're just left with x squared over 2. And so then when you have to find f double prime of 3, all you have to do is plug in 3 to this equation. So it's 3 squared over 2 plus the square root of 25, which equals 9/2 plus 5, which therefore equals 19/2. So that is A. And I'll just zoom out a little bit so you can see the full process. And then moving on to B, we are asked to find dy dx, which equals x times the square root of y at f of 3 equals 25. So first what you have to do is cross multiply. So you bring over the dx to this side, and you bring the radical y over to this side. So you're left with dy over the square root of y equals x times dx. And then from that you integrate. And so I rewrote this term and brought this up to the top, so it becomes y to the negative 1/2 dy equals the integral of x dx. So then once you integrate, you add 1 to this, to your top term, you know that, and then you divide by the reciprocal. So it becomes y to the 1/2 divided by 2 over 1, or divided by 1/2, which is just really times 2. So that, and then that's the left side, and the right side equals x squared over 2, and then plus c, which is your constant. And then your next step, therefore, is to solve for c. And so, well, first you have to, solve for c. So you go back up to where it tells you to solve at, and that's at f of 3 equals 25. So then you can plug in for where you're solving at, and so you get 2 times the square root of 25 equals 1/2 times x, which is 3 at this case, at this point. And then, so that's 3 squared plus c. And then once you solve your basic algebra, you're left with c equals 11/2. So then you take this number and you go back to your equation that you solved for. So you go back to this equation that you solved for, and you plug in your c value, which is 11/2, and then you have to get y by itself to define this function. And so you bring over this 2 and you multiply by 1/2. So you're all left with y equals x squared over 4 plus 11/4 squared, because you multiplied this through, so this multiplied by x squared over 2, and then you multiply 11/2 by the 1/2 as well, so you get this common denominator of 4, and then you square it to get rid of this radical on the left side and get y by itself. And then you could also write that same answer as y equals 1/16 times x squared plus 11 squared if you wanted to get rid of the fractions and find this common denominator. But that's totally up to you guys. I hope that this helped. I hope that you guys can better understand this FRQ. It wasn't a very long one, and good luck!